Alright, so here's the problem. Our curve's gonna look something like that. Wasn't too rigorous. And then we have our equation right out of the book for traveling wave with attenuation. I'm wondering if when you mentioned that there were two different equations, if you're talking about his example problem that didn't have this omega t. I'll show that actually doesn't matter here in just a second. So we have so the first place I got hung up on was my amplitude. So okay, so the beginning of my knowledge here, the amplitude is 10, but I mean, this is attenuating. I don't know what the hell it would be back up here at time equals 0. And that kind of screwed me for a minute until I realized that this phase shift really doesn't matter. Okay, so this is 2/3 of a wavelength shifted. So you could figure out what this phase shift is, but it really doesn't matter because you can take this and slide it back and forth anywhere you want, and it's not changing the attenuation. All it's doing is changing when we started or stopped time. So my first change to this was I just said, fuck it. This is now 0. I'm just going to get rid of that, which now makes this 3. So that's simplified. So now we know that our A now truly is 10. Our phase shift goes the fuck away. So of course we know omega equals 2 pi f, and beta equals 2 pi over the wavelength. Wavelength here is 3. So now we could assume that this is traveling at the speed of light, use the wavelength to find the frequency, so we could deal with omega, but it really doesn't matter because we'll see we have 2 pi f and then t. So this is this t is the amount of time it took to go from this point to this point. The time it took to go one wavelength, which is one period. So we would be plugging the period in for t, which this is 1. Now we're just adding 2 pi to the inside of a cosine function, which doesn't change its magnitude, so this whole thing goes away. So now we're just left with y equals ae negative alpha x cosine negative, well, we'll just write this as 2 pi over the wavelength x. Okay, so now we just straight up plug in the values we have. Alpha's 10, or amplitude's 10. Our x and our y come from this point, so that's 4 e negative alpha 3 is our x. Cosine negative 2 pi over wavelength is 3. X is 3. That cancels. So now we just have cosine of 2 pi, which this whole thing now becomes 1. So now we just have to solve that. Divide both sides by 10, take the natural log, and then divide by negative 3. Gives you your alpha, which that was, whatever that was, 0.30 something, I don't know.